This video is about the difference quotient, and in this one I'm just going to explain what it is. It's defined to be the quotient or the fraction or the division of f of x plus h minus f of x over h. So this is what it is right here. This is what it means. If you consider some graph f of x, and so over here on the right I have a little graph that I've drawn, a function f of x. So here's the function f of x, and I want us to consider 2 points on it. This is the first point right here, and this is the second point right there. And what I've done is I've named the first point to have an x value of a. So if I wanted to talk about the coordinates of this point, the xy coordinates, it would be x would be a, and the y would be f of a, the output. And here is the second point a little bit to the right of the first point. I've named it b. The coordinates of this point would be b, f of b. So if you draw a line through any 2 points on a graph, that is called a secant line. So I'm about to draw a secant line on this graph. I'm going to draw a point between these two points. So let me see here. Okay. Right here. There's my line. It's going to go through there. So this is a secant line of this graph. All right. There's our secant line. So if we consider slope, and I know that you are familiar with slope, m is equal to rise over run. It's equal to the change in the y values over the change in the x values, or the difference in the y values, y2 minus y1, over the difference in the x values, x2 minus x1. So I'm going to apply the slope formula for these 2 points to find the slope of this secant line. M is equal to, in this case, f of b minus f of a over b minus a. All right, so that is the slope of the secant line. Now I'm going to redraw this picture and rename the same elements of this slightly differently. So here is my x-axis, and here is my y-axis, and here is my function. This is f of x. And here is the first point here called A, what I called A, and here's another point here, what I called B. Only this time I'm going to name this point X. And this time, so its coordinates will be X, F of X. And this point I'm going to name not X, but X plus a little bit further down the x-axis, x plus h. So if that is f of x plus h, then the output will be f of x plus h. So what is this h? It's the distance from here to here on the x-axis. That's what h is. So let me get this out of the way just so I can see. So if I draw a line through these 2 points like this, there is my secant line. If I want to know the slope of the secant line, then I will again calculate y2 minus y1 over x2 minus x1. So in this case, instead of having f of b minus f of a, I will simply have f of x plus h minus f of x. That's the difference in the y coordinates, y2 minus y1, over the difference in the x coordinates, x plus h minus x, x2 minus x1. And we can simplify this. This will be f of x plus h minus f of x. Down here we have x minus x, which sums to 0, leaving us with just h. This is the difference quotient. The difference quotient we see is simply the slope of a secant line. The slope of a line passing through any 2 points on a graph. That's what the difference quotient is. Now, how does this relate to what we need to know? We're in pre-calculus, so the next course you take is calculus. And calculus talks about not the slope of a secant line, but the slope of a tangent line. So, or instantaneous slope. So what we do in calculus is we add this, a limit as h approaches 0 to this difference quotient of f of x plus h minus f of x over h. So if we look at this graph right here, this right here is the distance h, right? But if we look at as h gets closer and closer and closer to x, let me draw a bigger picture because this is hard to see. Let's see here. Here is my little graph. Let's see what I could do here. What if I do this? Okay, let's say this is x, and this is x plus h. This is x, f of x. These are these 2 points. Okay. So right here, between here and here, this is h. But as the distance h gets smaller and smaller, we would have a secant line like this. But what if h was only this far away? Then we'd have a secant line like this. But what if h got closer and closer and closer to x, so that was right on top of it? Then we'd have not a secant line, but what is known as the tangent line to a graph, or instantaneous slope. So the limit as h goes to 0 of the difference quotient is known as instantaneous slope, or the slope of a tangent line, also known as a derivative of a function, derivative of f of x. So this is what you'll be learning about in calculus, and that's why we need to get to know how to do it in pre-calculus.